Now we are going to enhance the calculator further. But let's first talk about expressions. Sometimes we think of expressions in a mathematical way. This expression equals this other expression, or this value. And this is a perfectly good abstraction in most of the cases. But in reality, we know that evaluating an expression takes effort and time. And if we have a more complex expression, there might be an order in which the different parts are evaluated. Order of evaluation and whether an expression is evaluated or not will be of importance later on. We'll come back to that. And evaluating a longer expression may take more time than a shorter one. But what is more important, imagine that we have a long expression and we have evaluated it once. And that we have to evaluate it again if we want to get the value later on. So we have to go again through the whole effort. Wouldn't it be great to have a way to remember value for future use? Now, in the previous video, we have considered a calculator like this. Numbers and the 4 basic operations. Now we are considering a calculator like this, where we have memories. And we have some keys for storing or getting values from this memory. In this case, we have just one memory. Memories allow us to store value for future use. A memory might hold a value, and there might be operations associated to it, like MS to store a value, and MR to restore it or to recall it. Sometimes there's even a third key, MC, for memory clear, but we don't need that. And I'd like to call the 2 keys to set and get like this. Set to set or store a value, and get to get or restore it. We will have the set-get idea later on elsewhere. Now, this memory just holds one number. So there might be additional memories for storing additional values. We could have, therefore, several, each with its own name, M1, M2, etc. For the moment, these names will be predefined. But rather than having these awful names M1, M2, etc., we'll rather for the moment call them X, Y, as we used to in math. And we will call them variables instead of memories. We could now discuss about what is the initial value of a variable, one that is stored before we set it to any value. We could say that it's undefined. So if we could then try to get the value stored, we would get an error. Well, in calculators, where they have numeric variables, this value is normally set to 0 in order to avoid the error. But this is an issue we would need to take later on again. Now we want the display to show something when we press the set or get key. Let's first talk about set. Imagine that we have a 3 on the display and that we press the set key of variable x. The value 3 would be then stored in variable x. And the display could show something like x equals 3 semicolon, in order to record what we just did. We say that we have assigned 3 to variable x, and we call this x equals 3 an assignment statement. Once we have set a value in a variable, we might use this value in expressions. For example, imagine we have a 5 on the display and want to add the value of x. We would press the plus symbol and then get x. In this way, we would see on the display 5 plus x. But this is an expression, and before we had an assignment statement. What is the display really showing? Expressions or statements? Well, we can normalize that to statements, and we can convert, we can think of expressions in these calculators as statements by considering that the display can also be seen as a variable. a variable with direct input. This is why we wrote the d equals before the expression. In this way, we have converted the expression to a statement. And the display in this calculator always shows statements. Now, in this video, we have introduced the assignment statement that helps us to assign a value to a variable. To the left of the equal symbol, we have the name of the variable. And to the right, the value or the expression we want to assign to. In general, there might be an expression on the right-hand side. We will need to evaluate the expression first and then assign the resulting value to the variable. Now, these expressions might also have variables. For evaluation, we might need to look up the values stored in the corresponding variables. Now, it might be even the case that the same variable appears both on the left and on the right-hand side of the assignment. Let's analyze this in more detail. But before, let's remember that an assignment statement consists of a variable followed by the equal symbol followed by an expression to be evaluated. We close up with a semicolon. Now let's try to understand the sequence of assignment statements as we can see here. To help our understanding, we will draw the variables with the values they hold. Imagine that we have three variables, x, y, and z. We don't know the initial values. We have a first statement that assigns 1 to x. So after execution, the content of variable x is 1. The rest remains unchanged. The next assignment statement is y equals x plus 1. First, we have to evaluate the expression at the right, x plus 1. To this end, we need to get the value stored in 1. So the expression to evaluate is 1 plus 1, so 2, and 2 is stored in y. We always work from right to left. First, the expression has to be evaluated and then stored in the variable. Now, in this final assignment, we first get the values of x and y, add them together, 3, and store 3 in x. Bear in mind that what you see on the left is what you have to type. And what you see on the right is what you have to think. In future, you will need to be able to reason without having to write it explicitly down. The variables together with the values is what we call state. An assignment statement therefore transforms a state into a state. Here is a notation to express what we are thinking of. You can imagine the states written between the statements. You see that this notation has curly brackets and the values of the different variables between these curly brackets. Now we have seen that we have further extended our calculator. After the calculator that could just show values, and the one that showed expressions, we have seen now a further one that displays statements. The assignment statement changes the values stored in variables. And we have called the collection of values in variables state. The assignment therefore produces a change of state.